Hi guys, how are you doing today? It's Miss H that we will be together with you. This is CM200 class and we are going to learn exponents today. Okay, how to work with exponents. By the way, do you hear my voice? It depends up to you. This is free class. If you want, you can come. Ethan, why do you say this? Okay, then now do you hear my voice? I think it's yes. Let's start to do the lesson. Okay, thank you. Thank you. That's great. Here we have some rules. First of all, what is exponent? Let's have a look for that. A is any number and b is an integer, a to the power of n. So be careful, the power, the exponent must be the integer. It can be positive or negative. Now it's integer. So a times a times a times a times a, n times a, n copies of a, when we multiply a n times by itself, it's going to be written as a to the power of n, as you see here in the circle. So a to the power of 4, here's an example, a times a times a times a, 4 copy of a is multiplied. And if a is 0, a to the power of 0 is 1. This is important, a to the power of 0 is 1 when a is different from zeros. Okay, so it has to be, the base has to be different from 0 because 0 to the power of 0 is undefined, guys. Okay, undefined, unknown. A to the power of 0 when a is 0 is undefined. But for the other numbers, like 7 to the power of 0 is 1, 12 to the power of 0 is 1, 1000 to the power of 0 is again 1. 0 power of any number except 0 is 1. Okay, again, here we have, let me show you this. A to the power of -1 is 1 over a. Again, a must be different from 0. Non-zero number, okay? A is non-zero number and a is different from 0. Why? Because 1 over 0 is undefined again, is undefined. Okay, so let's go back here. A to the power of -n is equal to 1 over a to the power of n. But before, previously, I want to show you here, this example. I want to show you this one. After that, I will teach you that. A to the power of m to the power of n is equal to a to the power of n to the power of m. They are same thing, and it's exactly equal to a to the power of m times n. We multiply power of power. It is called power of power. So m times n, a to the power of m times n. Also, it can be separated as a to the power of n to the power of m. No, you cannot unmute yourself. We don't do Kahoot today. If you want to say something to me, you can text to me. Text is open, text box is opened, chat box is opened. Okay, you can text to me. So that's why a to the power of -n here, the second property, a to the power of -n, is equal to, it can be written as a to the power of -1 to the power of n, right? So what was a to the power of -1? It was 1 over a, right? And to the power of n, so it's going to be 1 to the power of n over a to the power of n. We know that any power of 1 is 1, right? So it's going to be 1 over a to the power of n. Is this understood? A to the power of negative n is exactly 1 over a to the power of n. And negative means minus. When we put negative in front of a number, so we know that it changes the direction, right? So if it is in numerator, it goes to denominator. If it is in denominator, it goes to numerator. So this minus changed the direction. And the next one, let a be a non-zero number again. A is different from 0. This was the same thing, right? Yeah. Okay, next one, product of powers, same exponent. So I can do this for you here. A times b to the power of m can be a, what was that rule? Distribute law. So we can use distribute law. A to the power of m times b to the power of m. So if we have two exponential numbers whose exponents are same, bases are different. Okay, whose exponents are same, bases are different. So we can write them as a times b to the power of m. Here we have, as you see, a to the power of m divided by a to the power of n. I can show you here a to the power of m over a to the power of n as a fraction. It's going to be a to the power of m minus n. If you don't understand anything, you can text to me again. And the next one, again, the powers are same. Do you see that? The powers are same, the exponents are same, so we can write it as a over b to the power of n can be written as 1 by 1 a to the power of n over b to the power of n. So we did this. Next one, 1 over a to the power of n is exactly 1 over a to the power of n because I told you, right? 1 to the power of n. Okay, I will go slower if you want to. We will solve exercises about them. I will explain all of them one more time when we solve the exercises, okay? And product of powers, same base. A to the power of m times a to the power of n. If the bases are same, a to the power of m plus n. I can show you here why. A to the power of m times a to the power of n. What is the meaning of a to the power of m? Remember? A times a times a times. How many a are there? M, right? M times m copies. This m times doesn't mean multiplication by m. And there are n times, n copies of n are multiplied. A times, and how many times a are multiplied? N. Altogether, how many a we have here? How many a we have? M plus n. Good, bravo. So I can write it easily, a to the power of m plus n. Maybe you can confuse, for example, I can write 3 to the power of 7 times 3 to the power of 2. So here we have 7 copies of 3, sorry, here. 3 times 3 times 3 times 3 times 3 times 3 times 3, right? This is 3 to the power of 7 times 3 times 3. So this is 2 times 3 squared. Altogether, how many 3 we have? There are 9 3s, right? So the answer is 3 times 3 to the power of 9. So, but instead of writing the long way, Exactly, Matthew. Very good. Instead of doing this, we just write 7 plus 2. Okay, 3 to the power of 7 plus 2, which is 9. Okay, so if n is even, okay, let me show you this one more time. For example, negative 2 to the power of 5 and negative 2 to the power of 5. What do you think about them? Are they same? No, they are not same. Good. They are not same. No, you're writing. Good. Why? Because negative 2, all negative 2 is multiplied 5 times by itself. The results will be same because 5 is odd number. The answer is same. The answer will be same. But because of that power 5, I will show you the next one. What I mean, you will understand. The answer is this negative negative makes positive. This two negatives makes positive, and we have negative. How many two we have? 5. The answer is negative 32. But this means negative ones. Only one we have, right? 1. And then 2 times 2 times 2 times 2 times 2. So the answer will be same, but they are exactly two different expressions. Okay, because look at that. What about negative 2 to the power of 4 and negative 2 to the power of 4? What do you think? The results are exactly different, right? So because this is negative 2 to the negative 2 times negative 2 times negative 2 times negative 2, and this will be negative is only once. Okay, the power contains only 2, number 2. Okay, this power, this exponent is only the exponent of 2. 2 times 2 times 2 times 2. So it's going to be minus. So this result, this 2 is positive. This 2 is positive. The answer is positive 16. But this result is negative 16. Okay. Is this understandable? Does it make sense? Okay. So here, according to that, power of negation. If n is even, so when n is even, like negative 2 to the power of 4, negative 2 to the power of 4, when n is even, the answer is going to be positive. So it's going to be same as 2 to the power of 4. But when n is negative, when n is odd, negative 2 to the power of 4 is exactly negative 2 to the power of 5 because the answer is negative. Okay. Let's go to solve exercises. Okay, then it's your turn, guys. The first one. Try to do first one. You can use piece of papers. You can use, this is not number sense. If you did number sense sections, it was just mental math problems, but this is not. Okay, so you have to solve the questions so you can touch the piece of paper. It's your turn, guys. Yes, yes, if you want to, you can type the answers in chat. But please write, when you write the answer, because just we are writing 2, 3, so what do you mean 2, 3? A is 2, B is 3, for example. Write them like that, okay? The answer of like A2 or A3, what you get? Yeah, like that. Very good. That's great. Okay, let's start. I think you all finished that. So 2 to the power of 0 is 1, right? 3 to the power of 0 is 1. Negative 4 to the power of 0 is also 1. Don't forget, negative 4 to the power of 0 is negative 1, but negative 4 to the power of 0 is 1. Okay, when we have parentheses, the 0 power of any number, any non-zero number is 1, we said. And this is, it doesn't matter what it is inside the parentheses. So to the power of 0 is again 1. So what we have, 1 minus 1 is 0. So the answer is 2. The second one, we will calculate the inside. 25, right? Minus 8 plus 1, negative minus 16 to the power of minus 2. So it's going to be 25 minus 24. What is that? This 2, the fast calculation, right? So we have to combine some of them easily to get the answer. Negative 8 minus 16 is exactly negative 24. 25 minus 24 is 1. 1 plus 1 is 2. 2 to the power of negative 2 is exactly 1/4. Yes, very good. 1/2 to the power of minus 3. So what we said, this is exactly 2 to the power of negative 3, right? Or you can see that this minus changed the place of denominator and numerator. Or you can write just directly 2 to the power of 3. This is the same. Okay, 1/2 to the power of negative 3 is exactly 2 to the power of 3. The negative shows us, negative power shows us change the place of denominator and numerator. Is this okay? Yes, this is 8, exactly. Now we have two minuses. So when we have two minuses, how can I? When we have a minus in the exponent, okay, just make it upside down or just write it as fraction, but keep the number as itself. Okay, so it's going to be, it is negative 2, so it's going to be 1 over negative 2, right, to the power of 1. So to the power of 1 is just not necessary to write. So the answer is negative 1 over negative 2 or negative 1 over 2. They are same as negative 1 over 2, right? It is negative 1/2. Is this clear? 1 over negative 2 to the power of 1, so it is just negative 1/2. And this one, again, negative 1 to the power of negative 14. Negative 1, if you get confused again, you can write it as 1 over negative 1 to the power of 14. Do you see that? 1 over negative 1 to the power of 14. The same rule what we use. N to the power of, sorry, a to the power of negative n. What was that? 1 over a to the power of n. Do you remember? So what a is, it doesn't matter. Whatever a is, you can use the formula. So 1 over -1 is -1 to the power of 14. When 14 is even number, so it's going to be plus +1. Okay, the last question here, let me solve it here. 1 over 4 to the power of -3, is it? Like example C. And then what is the meaning of -3? What was that? Change the place of numerator and denominator. So it's going to be 4 to the power of 3. So it's going to be, what is that? Did we learn this? Remember? 4 to the power of 3 is exactly 64. Now the second one. Okay, go ahead. You have 30 seconds to solve the second one. Write this as power of 4. So the answer is coming. Yes, you're right, Angie. First, convert it as power of 2. Okay, convert them all to the power of 2. Edward, I found different result, but maybe you are correct. Edward, I found different result. Let's see. Let's see. I found, okay, go ahead. Just write the result. It doesn't matter. Write the result. I'm not testing you, right? You are working. I didn't find that result, not 4 to the power of 9, but we will see together. Okay, time's up. This is 2 to the power of 5, it's okay, times 8. What is 8 in terms of 2? It's 2 cubed, right? Good, but 8 is only 2 cubed. To the power of 3, because it's 3, this power, we cannot ignore the powers. We have to take every number, every single number as itself. That's 16. How can I write 16 as power of 2? 2 to the power of 4 and the square. We cannot ignore the powers. Okay, go ahead, switch it. Now, 2 to the power of 5 times 2 to the power of 9, right? Times 2 to the power of 8. 4 to the power of 6. Are you sure? Let's see. Now we will add all exponents, which is 14, 22, right? 22. Now, how can I convert it into 4? So, instead of 22, can I separate 22 as 2 times 11? 2 times 11. And the rule, how was the rule? Do you remember a to the power of m times n rule? It will be written a to the power of m to the power of n. So inversely, I can write it as, this can be written as 2 to the power of 2 to the power of 11. What is 2 to the power of 2? Which is 4. You're good. So this is exactly 4 to the power of 11. You see? We are playing with the numbers. 4 to the power of 11. Are you sure that is 611? I think it's more. So we cannot with exponential numbers, why we are using exponential numbers? Because very big numbers can be expressed by simple number. 4 to the power of 11, it's a very huge number. But we don't have to write it down. 4 to the power of 11, that's it. Okay? Let's continue with the third question. Okay, as a power of x times a power of y. Yeah, so write this answer, simplify this expression. So the answer will be x to the power of something times y to the power of something. Okay, so this is the expression. It's your turn, guys. I don't show you the whole page because, as I said, it's going to be very, very small, you see, to make it. Just a second, guys. Okay, guys, let's start. Now, when I open all of them, because they're all in multiplication form, right? So it's going to be x to the power of 4 times y to the power of -2 and times x to the power of -1 times y to the power of 5. So we will combine like terms, x to the power of 4 and x to the power of -1 times x to the power of -1 times y to the power of -2 times y to the power of 5. So when we add their exponents, we will get x to the power of 3 times y to the power of 3. And one of you wrote, and it's very good, Angie and Edward, also, you wrote this is as x times y to the power of 3. But the question says, write your answer as a power of x times a power of y. But I hide the question. That's why this is correct too, but the question wants this answer, x to the power of 3 times y to the power of 3. Is this okay? Do you have any question? So then I'm passing the other one. Okay, so we have another different type of question. Here, when x is 1 and y is -1, find the value of this answer. What does it mean? You will substitute 1 instead of x and -1 instead of y, and you will calculate this expression. Okay? And okay, one by one, let's go one by one, okay? Just 30 seconds. You have 30 seconds. Plug in 1 and -1. Okay, x is 1, y is -1. Okay, time's up. 15 times 1 squared. And please put parentheses. If you don't put parentheses, you will get the wrong answer. I showed you, right? Do you remember? -2 to the power of 4 and -2 to the power of 4, exactly, they are different things. Remember? So put the parentheses. And -1 to the power of -3 plus 18 times y now at first y, which is -1, times x1 to the power of -1 plus 27 times 1 times -1 to the power of 4. This is 1. What about this? 1 over -1 or -1 over 1, does it matter? It doesn't matter, right? So it's exactly -1 to the power of 3. So it's -1 because it's odd number, right? So it's going to be -15. This is -1. So this is -1. So by using, okay, let me write one by one if you want to. Don't go so fast, right? 15 times -1 plus. This is -1. You see that? This is 1 to the power of -1, so it's 1. It's exactly 1. So again, it's going to be -18 plus. So what is that value? This one? It's 1, right? So this is 1 because of even number power. So this result is going to be 27. And then we have -15 minus 18 plus 27. So it's going to be negative 33, right? Negative 33 plus 27 is negative 6. Did you get the same result like that? Let me check. I think yes, Angie found, Edward found. Okay, so is there any question? So let's have a look, the fifth question. Again, you have 30 seconds. The fifth question, you have 30 seconds. Okay, you are finding the answers. Let me expand it here, just a bit, make it bigger. I think yes, yes, record, because the class is recording now. No, it's not, you don't have to record it, it is recorded. And it will be sent, as I know. Okay, -1, do you see that? Negative here, negative sign is out of the number, right? -1 to the power of 2004. But this one inside, -1 to the power of 5, -1 to the power of 2005, this is odd number. That's why the answer is -1. So this is just +1, right? This is, it doesn't have any minus. And minus, again, this is as itself 1. Okay, minus is outside. Let's check the first one. This is exactly -1, right? -1. -1 plus 1 minus 1. When we simplify 1 minus 1, 0, the answer is found as -2. No, you are not able to yourself unmute. If you want to say something, you can text to me. Text chat box is opened, as you see. But there are, how many people we are here? We are 56 people. If I let you to unmute, so everybody will talk, and I cannot make my lesson. Okay? Okay then, guys, sorry about this. Okay, what part you didn't understand? What part you didn't understand? Can you tell me? Okay, if you don't, or later you can write. Okay, then sixth question now. What is the value of n? So here you have, what is value of n? Let me write shortly the question. What is the value of n? At 15, mostly the exponents. The rules, I think. For example, negative rule, for example, which rule you don't understand? Because I cannot explain it all from the beginning, especially this one. Okay, Edward, just once, okay? Or I will expel from the class. Only one time, Edward. The answer, negative rules. Okay, let me explain. After finishing this example, negative rules, I will explain it one more time. 1 plus, first of all, so square is outside the rule, right? So it's going to be added. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 is 21, right? 21 squared. It's equal to, what is that? So what is n cubed? 1 cube plus 2 cube. So let's start finding 21 squared. What is 21 squared? Good, bravo. Which is 441. right? 441. So let's start to do that. 1 cube is 1, 2 cube is 8, 3 cubed is 27. What is next one? 4 cube. What is 4 cube? 64. Remember, what is 5 cubed? 5 cubed. 125 plus, what do you think? Their sum is still 441. What do you think? I think no, not yet, right? So the next one, 6 cubed, is 216. So let's have a look because this is 200, 300 something. So I think we got this, right? When you add them together, when you add them up together, so 216 by 64, you can add them. 27, 8, 35, and you can add with 125. 35 is 160, right? Plus, what is that? 270, 280, and then plus 1. So as you see, it is 441 exactly. So what is this, the last number? What was the last number? 6 cubed, right? So it's going to be, you can write this, but it doesn't work for all numbers, guys. 1 plus 3 plus 1 plus 2 plus 4, 3, 4, 5. 6 squared is exactly 1 cube plus 2 cube plus 3 cube plus 4 cube plus 5 cube plus 6 cube. Yeah, it works for that. Okay. Let's I told you that I would like to solve negative exponents. Let me clean up all this. Okay, negative exponent one more time. A to the power of -1 is 1 over 8, so we have to send it down. Okay, but if it has more than 1, if it has different number from 1, like -2, it's going to be 1 over a squared. If it has a to the power of -3, it's going to be 1 over a to the power of 3. Okay? If we have like that, 2/3 to the power of -1. So we will change upside down because negative means change direction. Okay? Normally, in daily life, we are not using negative numbers, right? Did you ever use, I have -$10? No, of course. But negative, when do we use negative? When we show temperature, for example, under 0, it is -10 centigrade degrees. Very cold, right? It's very cold because it's under 0. It shows direction. So again, this exponent negatives change place of numerator and denominator. So it's going to be 3 over 2. Again, 2/3 to the power of -2. So what is that? This minus say that change place of denominator and numerator. Okay, I changed it, 3, 2. And this is the power. That's it. So it's going to be 9/4. Okay, again, negative power. So, and we have -2 to the power of 4 and -2 to the power of 4 here. They are different things we said. They are not same. Why? Because this is -2 times -2 times -2 times -2. So it's going to be plus, because these 2 makes plus, these 2 makes plus, positive 16. But this one, the minus is outside the rule, outside the exponent, right? -16. Yeah, good. When we have both base and exponent negative, -2 to the power of -4, what we're going to do? -2 to the power of -4. I will do the same thing, guys. But first, I will start with this negative power. Okay? I'm going to do that. This means inside the parentheses becomes fraction, which means 1 over -2 to the power of, but I will keep the same power, 4. Okay, I'll keep the -2 as itself. And then now it's going to be, this negative becomes positive, so it's going to be 1 over 16. Okay, I hope it will be helpful for you. Now, let's go with the other one. Seventh one, question 7. N is an integer such that n cubed is 4,913. What is the value of n? What should it be? We don't have calculator, right? So how can we do that? For example, how can I start? 10 cubed is 1,000, right? Okay, let's start. There is no solution way like this, so you have to guess that. And what about 20 squared? 20 cubed is 20 times 20 times 20 is 8,000. So it's going to be between 10 and 20. And let me choose another reference point, 15. And then this is cube. I think it will help you. It will help you, right? It can't be 15 cube. Why? Because 15 cube will end with 5. The end number is 5, right? Do you see that? What about 16 cube? The end number will be 6 times 6 times 6 is going to be 216. So the end number is going to be 6 again. It's not 16. What about 17? 17 cube. 7 times 7 times 7 is 343. Yeah, I got that. So the end number is 3. So it's not. Okay, what about this? 18 cube. What do you think about 18 cube? It's an even number. Again, it can't be, right? This is even number. This is odd number. So I'm looking for an odd number. Okay, so 19. Again, you can see 19. 9 cube. What is 9 cube? 9 times 9 times 9. It's going to be 9, right? The end number. So my answer has to be 17. You can check, guys, with the calculator. When you multiply 17 by 17, you will get 289. And when you multiply it by 17 again, you'll get exactly 4913. Okay? You see, how did I find? So you can start from 20. 19, it can't be because end number is 1. And 18 can't be. Why? Because it is even number. My number must be odd number. And 17 works for that. And you can try 15, so it can't be less than 15, etc., etc. It has to be 17 found. Next one. Okay, so this will be again, let me change the position of my iPad. Here we have, I think you will see it better now. Susan's calculator has a key that replaces the number displayed with its cube. So when you enter a number, it gives you, for example, when you enter 2, it gives you 8. When you enter 8, it gives you 8 cube. When you enter this number, which is 512, for example, its cube. It gives you its cube. So how many times, the question, how many times must Susan press the cubing key to display a number that is greater than 10 to the power of 9? How many times? Did you understand? Is this understood? When I enter 2, it gives 8. No. When I enter, again, one more time, when I enter that, press that button, it gives me 512. One more time, what is 512 cube? Of course, we cannot get that what is 512 cube, but I can use approximation 500 cube. Can I get this? Approximate, because it doesn't ask me what is the number. How many times she should press this number to get the number which is greater than 10 to the power of 9? Can I use 500 to the power of 3 for the next one? What do you think? 25 something? Why no? Why no? The answer is, okay, Edward, I understand what you are writing. Please don't repeat it 100 times, okay? One is enough. I can read. 500 to the power of 3, approximately, I will see. Let's see, what is 500 to the power of 3? It is 5 times 100, right? To the power of 3, so which is 125 times 100 to the power of 3. So it is 125 times, what is that? 10 to the power of 2 to the power of 3. You see that? 125 times 10 to the power of 6. What do you think? Next step, this is the first press. This is the second press. This is the third press, still less than 10 to the power of 6, 10 to the power of 9. So when I enter one more time, when I press that button one more time, will I get the number, the result, which is greater than 10 to the power of 9? What do you think? Yes, right? Good. So the fourth one, after fourth trying, I'll get the number. The number will be greater than 10 to the power of 9. Because this will be when you cube, when you take cube of this, it will be exactly greater than 10 to the power of 9. Understood? This is approximately 10 to the power of 8, guys. Not 10 to the power of 9 still. Not yet. Okay? Because 125 is 10 to the power of 2, a bit greater than 10 to the power of 2. So when you combine with 10 to the power of 6, it's going to be 10 to the power of 8, not 10 to the power of 9. Is this understood? Okay, then. So let's go. How many positive integers less than 333 are powers of 3? Can you get that? Okay, then. So you have just 1 minute to think about that. Oh, sorry. Okay, let me finish this one and then I will give you 5 minutes break. Okay? Let me finish this one and then 5 minutes break you'll have. It's not 5. It's not 5, guys. You missed one thing. It's not 5, I can say. Why 6? Because I said, right? You missed one thing means it's 6. Yeah, you are right. Okay, then. So why? What is that? Yeah, include 1, 3 to the power of 0. You missed that. So this is 3 to the power of 0. So we have to start power of 3. 3 to the power of 0, 3 to the power of 1, 3 to the power of 2, 3 to the power of 3. We know that, right? I'm not repeating them. 3 to the power of 4. What is 3 to the power of 4? 81. 3 to the power of 5. And 3 to the power of 6. What's that? 6 to the power of? It's 9 to the power of 3. Let's see, what are they? It is 1. This is 3. This is 9. 27. 81. What is 3 to the power of 5? 3, 22, 43. And when you multiply this by 3, it's going to be greater. So it is not, right? Out of this, it is greater than 333. 729. Yeah, exactly. So exactly. So this is not. So there are 6 numbers. Okay, guys. So you have 5 minutes break. Okay, 5 minutes break now you have. And at 4:25 be here. 4:25. Don't be late. Yes, this is a break time, guys. And the class ends at 5 p.m. Okay, guys, I'm back. Are you there? I hope you are all there. Let's go. Let's start with that. Okay, so let's do that 2 of them. You have 1 minute to finish them all. That 2 questions. You have 1 minute. Guys, this is your turn. Are you working? We are doing problem 10 and 11, both of them. Okay, let's start. Time's up. So A, 2 to the power of 30 divided by 2 to the power of 2 to the power of 3, right? So it's going to be 2 to the power of 30 divided by 2 to the power of 6, one by one. If you continue like that in order, systematically, you can get the correct answer. So division, when we have division with the same basis, we just subtract the exponents, right? 30 minus 6. So the rule is 2 to the power of 24. Did you get the same answer? Yeah. Second one, B. Here we have, guys, we cannot subtract 2 to the power of 20, 2 to the power of 19, and 2 to the power of 18. We cannot subtract them. What will we do? We will do factorization. 2 to the power of 20, I can write 2 to the power of 20 as 2 to the power of 2 times 2 to the power of 18 minus 2 to the power of 1 times 2 to the power of 18. The next term. The next term, 2 to the power of 18. So 2 to the power of 18 is in common. Do you see that? 2 to the power of 18 is in common for all terms. And we have the last term has invisible 1. Do you see that? We have invisible 1 as factor. So 2 to the power of 18 is outside the parentheses. So what is left inside? 2 squared, which is 4. Then minus, yeah. Then 2, yes. And then the minus 1, one more time. So it's going to be 2 to the power of 18 times, what is that? 4 minus 2, 2, minus 1, 1. So the answer is exactly 2 to the power of 18. Do you see that? Factorization. Okay, the next one. When the expression is multiplied out, how many digits does this number have? 8. What is 8? 2 to the power of 3 to the power of 10 times 5 to the power of 22. Let's see what will happen. 2 to the power of 30 times 5 to the power of 22. So what is the multiplication of 2 and y? No, I'm not Miss Dahl. I'm Miss H. At the beginning of the lesson, I told you. 2 to the power of 30 times 5 to the power of 22. So look at that. 2 to the power of 32. Instead of 2 to the power of 32, can I write 2 to the power of 8 times 2 to the power of 22? Can I separate 2 to the power of 30 in this case? Times 5 to the power of 22. Now I will combine these two guys. These two now I will combine. This is 2 to the power of 8 times 2 times 5 to the power of 22. Do you see that? What will happen? Did you see that? Yes, exactly. 2 to the power of 8. Do you know what 2 to the power of 8 is? You can count with your fingers 2, 4, 8, 16, 32, 64, 128, and 256. Right? This is 256 times 10 to the power of 22. What is the meaning of 10 to the power of 22? There are 22 zeros at the end, right? So how many digits does this number have? 3 digits we have here, 3 digits and 22 zeros, right? 22 zeros. Let me write here like that. So altogether, this number has 25 digits. Okay? Okay, let's go. This is easy one. 30 seconds you have. Ten to the power of 93. It's a very big number, right? Many 93 zeros at the end. But you can make it like simple. If there are 4 or 5 zeros, if I subtract 93, what will happen? Let's see. Okay, not 93. I'm not trying 93. I will see the pattern here. What will happen? Or you can try with 6 zeros or 9 zeros, etc. But I think 5 zeros is enough to see that what will happen. 7, and this is 0, right? And this is going to be 9, 9. Yeah. 9907. Did I subtract correctly? Okay, so do you see that? The last two digit is just 707. Last two digit is 07. And the other previously, how many zeros you add here? How many zeros you add here? They will be all 9. One difference, if we have 5,000, 5 zeros at the end with 5 zeros, I will have, sorry, 4 zeros, right? I did at the beginning, so 4, sorry about that. This is 4. Yeah, at the beginning, I did 4 zeros and 2 nines. I get 2 nines, right? 4 zeros, if it is 10,000, I get 2 nines, and plus 07. So if we have 93 zeros, if we have 93 zeros, how many nines do we get? How many nines? 91. Very good. 91 nines we will get. So 999 and then 07. How many nines we will have? 91. So what is the question? The sum of its digits. So we will have 91 times 9 plus 7. So which is 819 plus 7. So which is 826. Right? Very good. Let's go the other question, that 13, sorry, this one. What is K here? And find 13 and 14. Yeah, there is a question. You have 1 minute. Is it -3? Okay, let's see. 3, same thing are added. So can I write this as 3 times 3 to the power of 3? For example, what is x plus x plus x? So it is exactly 3x, right? So a plus a is 3a. So if it is 3 to the power of 3, 3 to the power of 3, 3 to the power of 3, so this is 3 times 3 to the power of 3. And then 2 to the 240. What is 243 actually? Or when you, okay, let me get this. 243. 3 to the power of 5, right? Good. So I'm not writing 243, 3 to the power of 5 times 3 to the power of k. So it is 3 to the power of 4 equals 3 to the power of 5 plus k, right? Do you see what I did? Bases are same, we add exponents. So this is 4. So if two things are same basis, two exponents are same and their bases are same, so their exponents has to be same, right? So 4 is equal to 5 plus k, so k has to be -1. At the beginning, you can simplify it to, at the beginning, to find k is -1. Also, you can solve it by this way. 14. What is question? Express your answer as a number times a power of a times power of b. Okay, so we have 6a squared b all squared divided by 3a squared b cubed. I can see this better. This is my way. I can see, I can make the calculation this better. So now distribution law, you see, 6 squared times a squared squared times b squared divided by 3a squared b cubed equals 6 squared is 36 times a to the power of 4 times b squared divided by 3a squared b cubed. Now the same terms will be combined. 36 divided by 3 is 12 times a to the power of 4 divided by a squared is a squared, right? 4 minus 2, not 4 divided by 2. They are same actually, but the formula is 4 minus 2. We subtract exponents. And b to the power of -1, which is 2 minus 3. Okay, the answer is 12, a squared b to the power of -1. Okay, so on. What is the value of the fourth term of this sequence? This is easy, 30 seconds. Can you do it? This is first term, second term, third term. So what is the next term? This is the fourth term, right? First term, second term, third term. So the fourth term is exactly 3 to the power of 0 plus 3 to the power of 1 plus 3 squared plus 3 cubed. Right? So you will find this one. Yes, exactly. You are right. So the answer is 1 plus 3 plus 9 plus 27. Combine easy math. Use easy math. 10 plus 30 is exactly 40. Of course, you will do it in your mind. This is easy one. Okay, let's go. Express your answer as number times a power of x. Simplify, says easy. Okay, then, so 17 maybe makes you think. Okay, let's do 16 and 17. You have a minute again. Do you hear my voice? Yes. Where is that? Both of them. Both of them. Oh, sorry. Did you give me the answer? X squared. Yeah, 7x squared. Yes, that's great. Yeah. 7x squared. Who wrote? They are correct. Okay, then. So Okay, let's start. This one, 6 to the power of 0 is 1. 1x squared plus 6x squared equals 7x squared, right? This was easy. What about 17? And this one, there are 4 positive integers a, b, c, d, such that a cube plus b cube is 1729, and another 4 two numbers, c cube plus d cube, is 1729. So what are these numbers? Actually, this is the question. What are these numbers? You found them? Okay, have you found 1, 12, 10, and 9? Good, good. Yes, you are good. Let's see. The cube of the numbers from 1 through 10, but I think it's gonna be 1. Actually, you can see that if you know the cube of the number, you can see one of the numbers will be 10 cube plus 9 cube. Do you see that? This is 1000, and 9 cube is 729. What about the other two numbers? Okay, what about the other two numbers? Let's see. 1 cube is 1. I'm going to write here 1. 2 cube is 8. 3 cubed is 27. 4 cube is 64. 125, 216. These are from 1. What about 7? Is 343, and 8 is 5, 12, and 9 is, we just said is 29, and 10 is 1000, 11 is 13, 31, and 12 is, oh, I found it. Sorry, this is, so actually we found these two, that their sum is 1729, and as you see here, this one, 1728 plus 1, exactly 12 cube plus 1 cube is equal to 10 cube plus 9 cube, right? So this sum is 12 plus 1 plus 10 plus 9. So it's going to be 2032, the answer. Yeah. Did I write wrong? Sorry. Yes, you are right. You just caught me. Very good. Okay, then thank you. And next page, do we have something here? Okay, we finished. Quick review. Again, now you have that questions. Let me see the old page. Just a second, guys. How many questions are there? Yeah, oh, that's it. Okay, you have 1 minute to finish them all. No, no. Oh, let me see. Yeah, you have to catch. I didn't see that. These are answers, guys, so I didn't notice that. These are answers. So let me do that. A squared times b to the power of -2 times a squared, b squared, expanded form of ab squared, ab all squared, right? So we will combine like terms. This one, a squared times a squared times b to the power of -2 times b squared. So this is a to the power of 4 times b to the power of 0, right? This one, which is 1. The answer is a to the power of 4. The next one, a squared b squared plus a squared b squared. They are two same thing, 2a squared b squared. So the answer is given here. And here, a squared b to the power of -2 over a squared b squared. So a squared simplified. The answer is b to the power of -2 minus 2 is equal to b to the power of -4. So it is exactly 1 over b to the power of 4, right? Good. And so let me clean the answers. Now you have 3 exercises. And you have 1 more minute. Are you ready? Lisa, very good. Good then. So let's start. A to the power of 12, b to the power of -3 times a cubed. So distribute, right? This power to the others. A cubed, b to the power of 9. Now combine the like terms. A to the power of 15 times b to the power of 6. Is it correct? Next one. So just same thing. They are multiplication. So just combine like terms. So a to the power of 21 minus 6 times b to the power of -3 minus 3, a to the power of 15 times b to the power of -6. Sometimes it says that, as you see in the example exercises, it says that write the answer in terms of a to the power of something, b to the power of something. But sometimes they say that convert them into positive exponents. Okay, positive exponents. So you can write it as a to the power of 15 over b to the power of 6. So both answers are correct. This one and this one. So it depends up to the question. If it doesn't say, both of them possible. The last one. So just a to the power of 2 minus 17 times b to the power of -5 minus -15, right? So you don't have to confuse your mind. Just apply the rule. -5 minus -15. So a to the power of -15 times b to the power of -5 plus 11, right? So this is a to the power of negative 15 times b to the power of 6. So if you want to convert it into positive exponent, so it's going to be b to the power of 6 over a to the power of 15 because it goes down, right? Negative exponent, the exponential number. No, we don't play Kahoot today. No Kahoot. Sorry. Would you like to play Kahoot? If I knew that you'd like to, yeah, sorry about that. I didn't prepare Kahoot. Okay, next time if we have lesson, class together, I would like to prepare it. Okay, then let's check answers. What is that? Yes, correct. Wow, your teacher made it correct. Without mistake. Proud of me. Okay, oh, don't. Okay, then now, this one. You have a minute again. Are you ready? Did you finish? You finished? Okay, let's start. A squared, let's do this one. A squared, a to the power of 4, so it's gonna be a to the power of 6, right? Then b to the power of 15 minus 5, a to the power of 6 times b to the power of 15. Guys, these are like terms whose variables are same. Okay, in the same power and same variables. So this is like, you can see that like 1 apple minus 5 apples. Or if you don't know how to calculate that, do just factorization. Common factors, look at them. Let me clean up these circles. Okay, common factors. A to the power of 6, there are a, so they're all factors, right? So a to the power of 6 is in common as factor. Also b to the power of 15 is in common as factor. So what we have here, invisible factor, 1. So just factorize it. A to the power of 6 times b to the power of 15, open parentheses, 1 minus 5. So it's going to be negative 4. Always coefficient is written at the beginning, negative 4. Times a to the power of 6 times b to the power of 15. Okay, the next one, so do this operation. A to the power of 9 times b to the power of 12 times 3 squared, a to the power of 6 times b to the power of negative 4. This is 9. So combine like terms, but take 9 at the beginning, 9. A to the power of 15 times b to the power of, what is that? What is that? B to the power of 8, right? 8. The answer is this. And the last one. So let's see, because this is addition, subtraction, this is expression. Like terms. Like terms, this is the same exponent raised with the same power. Okay, same exponent with the same power, guys. So these are same like terms. As you see, negative 2c to the power of 11, positive 2c to the power of 11, they will be simplified. That's it. Then a to the power of 15, yes. B to the power of 8, yes. So these two are like terms too. And we just operate the coefficients. 9 minus 3 is 6, a to the power of 15, b to the power of 8. Okay, is this clear? Next one. Go ahead. You have a minute. No, at 5 o'clock. 1.5 hours. At 5 we will be finished. In 3 minutes. Did you get bored, Lisa? If we have less students, now we are 54, 55. If we have less people, we could talk to each other, it would be better. But this is free class, that's why we are a bit crowded. And what can I do? So I'm just talking. Sorry about this, but in the class, next classes, if you be there, it will be person to person. We can talk to each other online, but again, at least we can talk to each other. And so let's see, let's find the like terms like a to the power of 15, 5a to the power of 15, which is 6a to the power of 15, right? And then, and here, negative b to the power of 8 plus 2b to the power of 8 is going to be, what is that? Plus b to the power of 8, right? This is correct. So we have no 2, so 2 is just 11, a to the power of 11 minus negative 4, right? And then times b to the power of minus negative 4 minus 4. So the answer is 2a to the power of 50, a to the power of 15 times b to the power of negative 8. This is finished. Normally we finished, but we can continue to make exponent positive, like 2a to the power of 15 divided by b to the power of 8. The last one. And do we have time? 1 minute. Seconds left. Okay then. So a to the power of, so 1/2, I can write it here. A to the power of minus negative 3 minus 5 times b to the power of 10 minus negative 5. Negative 5. So I can write this. So 1/2 times a to the power of negative 8 times b to the power of 15. Do you see that? And to make exponent positive, so it's going to be b to the power of 15 is upstairs, and in downstairs we have 2, and this one goes to down as denominator. So the answer is b to the power of 15 over 2, a to the power of 8. Okay then, so let's check the answers. Yeah. Okay, so we are done. So 1 page left, actually. If you want to, if you have time, if you don't have any class, I would like to finish that page. If you have another meeting or another session, you can leave, but I will finish this one. So it's going to be 8 to the power of 6, b to the power of 15 minus a to the power of 6, b to the power of 15. So as you see, it's going to be 7, a to the power of 6, b to the power of 15. So here, like terms, there's no a squared, b squared. This is alone, so I cannot do anything. 3ab, ab, they are same. So when we add them, it's going to be 4ab and plus ab cube. So we can change their places. It doesn't matter. The important thing is correct coefficient. So the last one, this one and this one are like terms. As you see, 3 minus 2 is 1, a squared times b. And this is alone. There is no like term for this one. So it's going to be a to the power of 3 Oh, sorry. There are 3, right? This one and yeah, here, let me go. This one, these 3 are same, right? So this is -3 plus 3. So they are all simplified. If you notice that, their coefficients. So the answer is just only 3a to the power of 5, b to the power of 7. Okay. So we finished. Thanks for your attention, your patience. See you till next hour, next class if you have. Okay, stay safe. Take care of yourself. Have a good weekend. Bye.